will be there to assist.
Thank you very much, Molly. And following what the Minister Damboa's explained, and also Gabriel and Jeremy's explanation, I would like to provide a perspective from the practitioner like myself and from NG perspective, how a project can be structured and developed in Australia. Here, the example we're showing is the project NG and the YARA have been developing in the Pilbara region. The project is named as the YURI project. It's a green hydrogen to ammonia project. And currently, we are located by ARENA, 42.5 million from the federal government subsidy. We are in the process of financial close for this first phase. Meanwhile, we are interested to further develop the project to the next phase and also develop the Pilbara hydrogen hub based on YURI project as the building block. Next, please. To start with, my presentation will take around 15 minutes, and I will cover NG, what NG does, NG's hydrogen strategy, and the YURI project, and the Pilbara hydrogen hub. So 4 aspects I will talk. NG is a global reference company in the energy transition. If you can see the slide, a few numbers, the highlights NG's profile. NG has around 100 gigawatts of power installed. Out of that, have around 31 gigawatts of renewable assets present in 27 countries. Meanwhile, NG is also a large European site, the #1 natural gas distribution network company. The company has around 40,000 kilometers of natural gas transmission pipelines. NG's strategy is to be the early mover and lead the energy transition. Next, please. NG's hydrogen. Yeah, please.
Sorry for the interruption. A small suggestion from the audience, because the voice seems breaking, is it possible for you to pull out of your earpods and try to, receive voice recording with your own laptop?
Yeah, maybe I can try.
If that voice would be clearer than now.
If it's improved or it doesn't improve, no. So NG's hydrogen strategy is to be first mover to maximize the hydrogen market growth potential. The way we see the hydrogen to be developed is really from the area where it has big renewable energy potential, overlap with strong progressive government support. At the same time, as a company, we would rely on some of the energy system presence. With those 3 or 4 conditions together, NG will select certain area to start the renewable hydrogen development. The development will start with 1 or 2 or more anchor off-takers, such as industrial feedstock, heavy-duty mobility, and the other industrial process who could require hydrogen. When we start with a relatively local demand, we will also aim to have a large scale and potentially going to export. So if you can see this chart, we follow this logic. We start with area has good resources. We will build the first step. Then we will expand to make it bigger, scale it up with a longer term, trying to export from one country to another. The country has rich renewable resources. Certain countries have a deficit of renewable energy sources. So beginning of the year, the previous one, please. So beginning of this year, ENGIE Hydrogen set up hydrogen development target. By the year of 2025, the intention is to develop 600 megawatt of electrolysis capacity, and this will scale it up to 2030, around 4 gigawatts. Meanwhile, at the middle stream, the purpose or the target is to develop 170 kilometers of hydrogen transmission pipelines. This will increase to 700 kilometers by the year of 2030. At the storage aspect, we also intend to develop hydrogen storage capacity by the year of 2025, which 270 kilowatt-hour of hydrogen storage capacity. This will increase to 1 kilowatt-hours of capacity by the year of 2030. On the mobility space, ENGIE also has interest in the intention to develop refilling stations, increase from 50 refilling stations by the year of 2025 to more than 100 by the year of 2030. You can see as of now, ENGIE has in total around 80 gigawatts of electrolysis capacity in the development pipeline. These are represented by over 70 projects. Around 20 projects have a capacity more than 50 megawatts per project, and around 50 below 50 megawatts per each. Next, please. So ENGIE considered the hydrogen business will be a global business. This business is currently in the making. Either it will be big or it will not be. So from the starting point, ENGIE considered the hydrogen should be a global business unit. So in that context, ENGIE has been pursuing hydrogen projects globally. Over this chart, you can see on the bottom, the ENGIE group has done around 10 projects in the R&D stage, like a demonstration. And the projects, around the 12 projects on the global chart, those are the industrial projects ENGIE has been developing beyond the demonstration. The projects we have been developing here, around the 12 projects, you can see we almost covering all the area, all the countries that have renewable resources. It's covering Chile, South Africa, Australia, and a number of other countries also in this category. Meanwhile, ENGIE has quite a number of projects in Europe. So those are the projects as an example of in the public domain as an illustration of ENGIE's portfolio. On the right side, we have set up the table. You can see in the table, we are trying to group in the different projects into a few different categories. If you can see here, it covers mobility, heavy-duty mobility, that's including maritime, also including mining, as a mining trucks as a heavy-duty mobility basis. Also covering refinery, it could be oil and gas refinery, biorefinery. And the fourth category would be green ammonia or other chemical feedstock. The last one, the last but not least, is the natural gas blending. This is also a project in the HIG has been pursuing in Victoria, as mentioned earlier by Gabriel. Molly, I'm trying to collect by phone as well because I see questions.
Yes, I just sent you the phone dial-in number through the chat box because the sound is still breaking. To ensure the overall quality, I think we have to resort to plan B as discussed previously.
Okay.
Yeah, so I would appreciate every audience to be patient for 1 minute and let PingYang dial in using his mobile. Appreciate it.
Adele from the phone, can you hear me now?
That's very clear.
Okay, great, much better.
Great, and please resume the presentation. Thank you so much.
Thanks. Next slide, please. So for 𝐻𝐸 and the YARA, we have been collaborating since 2019 to develop a project in the Pilbara region to harvest the rich and abundant renewable energy in the Western Australia Pilbara region to produce renewable hydrogen feed into YARA's current ammonia plant to make green ammonia. The ammonia would be produced to serve the domestic market and also has the bigger potential to be exported to the Japan, Korea, and the broader Asia market. Next, please. The YURI project has multiple stages of development. Itself, currently the primary usage is for ammonia synthesis. Meanwhile, this industrial process can be added on top with other industrial hydrogen usage cases to become a Pilbara hydrogen hub. For the YURI project, we have a roadmap of 4 stages. The current stage of phase 0 is a project 𝐻𝐸 has obtained 42.5 million capital allocation from the ARENA tender program, closed or launched in May this year. Out of this industrial roadmap, the first step is to demonstrate the technology, the business case, and meanwhile to create a certain volume, be able to push to the market. As of today, there is this chicken and egg issue. Green hydrogen supply to the market to a certain degree is largely doesn't exist. The clients would be interested to buy this product or have the interest to buy this product, but there's no supply. So to break up this chicken egg dilemma, all interest or strategy is to create a supply first. So the phase 0 will be largely to create this supply and demonstrate this business model. Once we further develop the market, the technology development will also be following. We are going to scale it up to be 150 to 500 megawatts of electrolysis capacity. Once the market is further developed, the ammonia plant, a new ammonia plant will be built, and this will be further scaled up from the currently a small percentage of green hydrogen supply to be a large portion of supply. And the end game would be at a gigawatt scale in cumulative basis, and the current ammonia plant and the future ammonia plant will coexist and support each other. In addition to green hydrogen to ammonia route, the hydrogen once is produced in Pilbara, there would be a lot of potentials. That's including putting the hydrogen into the nearby Dampier-Bunbury pipeline, used as a natural gas blending usage. It could also supply hydrogen to the nearby mining operations, starting with as a mining truck fuel, and hydrogen can also be used as a process heat and feedstock supply, for example, as a green steel making in the Pilbara region. Once the hydrogen produced in a bigger scale, it can also be exported in a different form. It could be in liquid form, could be in other chemical compound, as a certain question was raised, like the MCH, the toluene-based liquid organic hydrogen carrier. So hydrogen hub is a key topic as of today in Australia. Recently, within last week, The Ministry of Industry of the Federal Government of Australia has launched a new tender program for grant application. In total, is 464 million. Has interested to support up to 7 hydrogen hubs, and the Pilbara is kind of identified as a most promising area, one of the 7 locations to be developed into a hydrogen hub. So the Pilbara Hydrogen Hub is a concept that has been identified by the federal government, by the Western Australian government, and also by the city of Karratha and the Pilbara region. As Gabriel mentioned, in Victoria there was there is 4 area so-called the hydrogen cluster, and in Western Australia I think also has multiple hydrogen cluster. Karratha city, it's around 5 or 6 kilometers distance from the Yarra ammonia plant, is also one of those 13 hydrogen clusters out of the different states. Next, please. For the hydrogen hub, it will need a significant volume of renewable energy production and the supply. We all know the challenge of the Pilbara has certain cyclone impact. Therefore, for the large renewable energy development, we will move inland. So we first are trying to avoid the 50 kilometers distance from the coastal area and move further inland, following the public infrastructure already exist to develop a renewable power assets. Those siting possibilities or the site corridor is largely the overlapping of certain existing infrastructure with a combination of the solar and the wind, where the solar and the wind have a different load profile. To increase the load factor of the renewable hydrogen production system load factor, we needed to use the combined solar and the wind to improve the load profile, to maximize the usage rate of the whole system. Next, please. When we mentioning the hydrogen hub, the hub is located largely in the whole Pilbara region. As you can see the previous slide, we have the interest to find the best combination of solar and the wind within inland of the Pilbara region. The purpose is use the pipeline to transport those hydrogen produced inland towards to a port to be exported. In the Pilbara region, largely there are the port headland and the port Dampier to for the current export of iron ore, other liquid, and also LNG. There is a good potential of the Dampier port for export of hydrogen or hydrogen carried by other carriers. Here is the zoom in of a portion of the Dampier port. You can see in the middle there is a circle called the renewable hydrogen. Actually, that's the phase 0 of the YURI project, where the renewable hydrogen will be supplied to the Yarra ammonia plant. From the Yarra ammonia plant, currently Yarra already exported ammonia to the Dampier port, the liquid valve. That distance is around 4 to 5 kilometers only. If you see this picture around the 5 to 10 kilometers distance radius, there are already ammonia plants, LNG trains, and other export infrastructures. So this area already has a lot of infrastructure could be benefit as the starting port and starting area of the hydrogen hub. So Molly, I think that's all of my presentation, largely covered the YURI project and the Pilbara hub concept. Back to you.
Thank you so much, PingYang, for your detailed explanation. YURI is quite a milestone and demonstrative project for the whole, I think for the whole Australia. And there are a lot of things that we can learn from the YURI project. But before that, I think we can go directly to the industry questions that was collected prior to the registration. If I may, can I invite you, to go through all the slides with me?
Sure, more than happy to do so.
So this is, the first question is actually being touched by Jeremy before, and being the investor and the developer side. Can you put some insights on it?
Yeah, so hydrogen as of today, it's a technology in the induction. As we all observed in the solar and the wind, when the new technology in the emerging, in the making stage itself at the beginning will have an economic gap. And this gap, as Jeremy mentioned, it needs to be spreaded or socialized to the mass public to support this technology to be developing to be a stage will be competitive. The potential of the cost reduction and this technology itself is well understood by a lot of engineers and by manufacturing experts. There is a lot of question in the chat box and the different people asking how renewable hydrogen or electrolysis could be competitive. There is companies, including ENGIE, we have done looking into the different components of the whole machine and the manufacturing process.